Are we live? Cool. But first, for anyone who has a drink, a toast to the last CarolinaCon as we know it. Cheers.
Yeah. So this is our talk on drilling deeper with Vail's PowerTools. It's kind of just going over the framework and some of the new additions and how we use it in engagements. So as you already heard, I'm 6Dub. I go by Justin Warner. I pen tester red team or adaptive threats division, do a lot of reverse engineering, kind of keeping up with what the bad guys are doing, come from a little bit of a defensive background, and try to apply that knowledge onto the offensive side to give people like real world assessments and make them work for their money, kind of learn some tactics. Developer on the Vail framework pretty recently, and specifically on the PowerTools side, diving into the PowerShell and PowerShell capabilities offensively.
Again, I know, thanks to the great introduction, I'm Will Harmjoy. I won't repeat all this stuff, but I was here last year. Christopher Trunser, one of the other main developers of the Vail framework. We talked in AV Evasion with the Vail framework. We had a great time. Chris is very sad, but he can't be there this year. He's out in engagement. He sends his regards. So hopefully we've got another cool talk lined up for you guys.
So some of the things we're going to be going over, basically highlighting the different features that are currently there, as well as some of the new features. And we're going to end this talk basically going through actual, like a real world scenario that you would walk through entirely using our framework in PowerShell offensively. Hopefully tying together some of the things you might have seen, like, a lot of people might have heard of PowerView specifically or one-off features. We want to show you how to kind of walk from no access all the way through having admin access just using the framework.
And one thing we didn't mention, these slides are actually live on SlideShare now. They're tweeted out under my handle Harmjoy, and it was tweeted at the CarolinaCon tag. So if you guys want to follow along. Cool. So introduction, kind of how we got here for the Vail framework. Got our little logo there. The Vail framework started with a tool called Vail Evasion, which we wanted to have a kind of generic way to generate AV evading executables when we were on pen test. It kind of evolved in this offensive toolkit that started to, kind of aim to bridge the gap between pen testing and red teaming capabilities. It expanded from Vail Evasion. There was a Catapult, which is kind of a payload delivery tool. Vail Pillage, which was presented at DEF CON, which is kind of a fully fledged post-exploitation framework, kind of like SMB exec. Then also Vail PowerView, which I spoke briefly about last year, PowerUp, like all these kind of additional tools we kept adding in. So they're not all, kind of one single tool. They don't quite make sense, but we think they make sense as a collection that we use offensively. And again, last year, CarolinaCon 2014, AV Evasion with the Vail framework. Vail's PowerTools. So we kind of had this, schizophrenic division for the Vail stuff. Now we have basically two repos is what we're going to be maintaining. The Vail repo, which has all the offensive Python stuff, with Vail Evasion, Catapult, Pillage, those types of things. We're actually in the midst of doing like kind of code-based rewrite to combine everything. And the second repo is a collection of all the offensive PowerShell stuff that we've gotten into. So Vail's PowerTools is kind of what we pulled that into. It'll remain the primary source for all offensive PowerShell work that we do, with everything in Python remaining in the Vail one. So really quick note, my workmates make fun of me because I won't shut up about PowerShell all the time. That's all I've done in the last year. But PowerShell, real quick, out of the box, like why you should use it. It provides full .NET access, application whitelisting, and AV evasion kind of bypass natively, direct access to the Windows 32 API, which we'll go over. You can execute everything purely in memory without touching disk, and it's installed on every machine when Windows 7 and up. If you're not using PowerShell as an offensive operator, you absolutely should be. There's no reason not to. There's this great post from Matt Graber, one of the PowerSploit authors, called Why I Chose PowerShell as an Attack Platform. The link's right up there. Also, bad guys are using it. This little PowerLix malware, Deep Panda. Bad guys and red teams are using PowerShell. There's not a reason not to. If you want to do a pen test or a red team and simulate real adversaries, you need to step up your tradecraft with this stuff. And Matt Graber's little tweet saying, "My offensive PowerShell awareness campaign can wind down now. It would seem that the criminals and state-sponsored actors have it from here." Yeah, there's been a major uptick in the last year or so. It's really kind of exploded. Mandy and AmirCon actually had a really cool talk on kind of triage and incident response against offensive PowerShell attacks. And also, had to put this quote in, PowerShell is basically Microsoft's post-exploitation language. It's one of my favorite quotes ever from ObscureSec, another one of the PowerSploit authors, so I had to get that guy in there. So PowerView, this is kind of one of the first tools introduced into the Vail framework that was PowerShell based. It started, I actually think I spoke on this a couple slides last year if you guys saw that talk, but It started with, the original motivation for it was we had a client that blocked all net.exe commands. So, we hit a box, we start trying to do our normal lateral movement and post-exploitation, and we're like, what the hell? Like, we can't do our normal, we can't even see who is in the domain and that kind of stuff. So I went back on the weekend and I rage coded a bunch of stuff up in PowerShell to do full replacements for net.exe. So it really kind of emerged as this DS query kind of on steroids. Anything you want to do for getting users, groups, trust, like there's 50 plus functions in it now. It's been one of my primary dev focuses over the last year. Otherwise, it was inspired by Rob Fuller Mubix, who spoke here last year. He has a tool called netview.exe, which is a C++ based tool to enumerate like shares, users, and all this kind of stuff on a Windows domain. Started taking some of that functionality and kind of porting it over. Invoke netview, I believe, is the commandlet that ports a lot of that functionality. One of the big uses we've had for PowerView, we use this on every single engagement now. So whenever we're operating, we have to figure out where users are logged in on specific machines. I actually gave a fire talk on this topic specifically at ShmooCon called ION Sysadmins. So for PowerView specifically, there's two main functions we'll use. Invoke User Hunter will query domain, pull all the machines down, go to each machine and enumerate the logged in users and sessions and match that up against a target list. By default, it's like domain admins. So you can push this button, you'll get a nice list of every single place where domain admin is logged in. You can even check to see if you actually have local admin access to the target machines you find. Invoke Stealth User Hunter does a red team trick where it actually gets all the file shares in a network. It does net sessions against those, remote net sessions, matches that up against a target list. So with very few calls, very few traffic, you can get a really good mapping of where a lot of users are logged in, a lot less traffic than Invoke User Hunter. Another cool thing that got added in recently because of this guy is offensive event parsing. So if you get domain administrator, it doesn't mean you're done. DA is not the goal. The end goal is access or showing impact in an advanced engagement. So a lot of times, once you get DA, it can be this really nice means to facilitate what your end target is. So you want to target IR guys, finance guys, Linux admins, whatever, right? But getting DA lets you do things like query all the event logs in a domain controller. So PowerView's get user logon events lets you extract all the 4624 logon event IDs from a domain controller, filtering for a specific user. I think by default it restricts the last 3 days. And Invoke User Event Hunter wraps this all up into a weaponized form. You run this with DA, give a specific user or target group or something like that, it'll tell you exactly where each person logged in at what time. So we use this really effectively on some engagements. Also, oh, sorry, this is you.
So kind of bridging into the domain trust stuff, obviously we were doing stuff with PowerView where we'd be able to query domain trust events. And so PowerView using GetNet domain trust and GetNet forest domains, we were able to kind of map out a network in order to, we can get all the domains and then the domains they're trusted with, and then we go to those domain controllers that they're trusted with and we do the same query, effectively spidering domains looking at the different trusts. When I came onto the project, the way we were visualizing this was like raw CSV output. But we run this in a 200,000 endpoint network, and some of our customers, like spread internationally, you get this, hundreds of thousands of line CSV, and it just wasn't very useful. And so I wrote a quick little script that allowed us to, in Python, import all this data and actually graph it in a nodal analysis kind of format. So kind of taking some data analysis or big data techniques and applying it to the enumeration stuff we were doing. And what that resulted in was this pretty little graph. And so you could actually, kind of drop into a customer environment, map all domain trust, and spit it out to a pretty picture so you can say, I would like to go here since it's at the center of 100 plus domain trust events, and likely would be able to crawl across those domains. The colors all here have a different meaning depending on the specific domain trust, and obviously there's different ways to graph it.
Yeah, this is a pretty complex topic. We both have a couple blog posts about this, but on my blog, the harmjoy.net, there's a really intense, really long, step-by-step post for enumeration, visualization, and abuse of these types of trust relationships. Or after the talk, if you guys want to come talk to us, I'm sure we'll geek out about it.
Sure.
So kind of one of the last things with PowerView is data mining. One of the really common methods of access we've gotten lately are insecured Windows file shares. So it used to be, kind of a pain. A lot of red teams would be like, all right, we're going to have our new guys enumerate every share and every file and triage everything. It can take weeks or months. But now with PowerView, you can do invoke share finder, check access. This will spit out every single share on a network that your user has read access to. Just dump it all into a list. Taking it one step further, you can do invoke file finder. This will do kind of an equivalent of a dir/s recursive listing, but it filters for file names with specific wildcard terms. So things like password, config, admin, things like that. So you can run this in every single share that you have access to, an entire Windows network. It'll dump out a CSV file telling you these are all the interesting files that you should go check out. You can also sort them by like last access time and creation time and stuff to triage what you actually want to go after. Cool. So power up. Automated Windows privilege escalation. We got our little Mario guy there. So this is another tool that was made because my boss pretty much made me do all this stuff manually on a red team engagement of go to every single service and go to every single service executable and check the permissions for every single one and see if there's actually a problem to privesc. So, we had to privesc on this particular engagement. Kernel exploits won't work. Fell back to doing it manually. The stuff that took like a day and a half for me to do, like there's no reason this can't be done in PowerShell and done significantly easier, more quickly. And later on, started porting in more stuff from, there's a great Encyclopedia Privesc article out there. Real quick, I'm going to go over a couple of the common Privesc vectors. Windows services, this is really kind of old school. People used to abuse like the vulnerable service permissions themselves. What's much more common to us are the permissions for the executable associated with the service. So if it's not installed to C program files or C Windows, it's installed to like C custom service, whatever, those permissions aren't locked down by default from all users. So if you can overwrite that executable, restart the service, either through the service control manager or rebooting the box, then you can privesc. And there's, the get service perms and get service exe perms and power up. For DL hijacking, this is another super common method. So many programs and services will search for multiple locations for DLLs that they need to load for proper execution. The very end of this search will be the path variable in Windows. So the end result is, if there's a folder in your Windows system path, so like C Python 2.7, C Perl, C, totally not Lotus Notes, I promise that doesn't happen. You can escalate on a Windows machine 100% of the time, at least for Windows 7. I'm pretty sure there's a couple methods for Windows 8 as well. So invoke find path DL hijack will enumerate all the folders in your path. It'll check to see if you can actually write to it, and it'll report back everything you can escalate. The power up, it wraps all this stuff together. You can execute any number of these checks manually, or you can run the invoke all checks, which will run all the current checks, give you a nice report out. We'll do this in the demo right at the very end. There's actually a couple of abuse functions you can use, like you can write out a service exe, we're working on the DLL, write an MSI that adds a user and that kind of stuff. All that's completely contained in the script, so you don't have to manually create a service, like patch everything and whatever else. It's kind of this all-in-one Windows Privesc auditing tool, and it's been super effective. I think probably like 70% engagements we're on, we usually find something that lets us escalate.
Yeah, it's definitely one of the first things we do when we get on, an engagement where you have a week or a couple weeks. We will, evaluate the local image if they give us one and run the script. And, oftentimes where we find one, we find it on everything. So, the next step is PowerPick. So when I came onto the project, we started to have this fear that someday our favorite framework or our favorite scripting language would be blocked. Someday an administrator is going to figure out how to block PowerShell. And so we realized that might be our single point of failure. And then we actually ended up on an engagement together right after I started working, where the administrators and the network defenders effectively used HIPs to flag on PSSX PowerShell. And so we started to see that possibility more and more real. And we wanted to actually prepare for situations like this. And so I developed PowerPick kind of as a, not perfect solution, but a demonstration that it's not quite so easy to do this. And so I actually used .NET and C# specifically to implement like the system.management.automation, which allows you to define run spaces in, like PowerShell run spaces in C#. And then I wanted to see if, like what that looked like on the host indicator level. I have a big blog post on this. This came out, I guess, a couple months ago, where a lot of discussion was generated. And effectively, what it allowed you to do was defeat blacklists. Whitelists are, the best way to go. Obviously, it's more ideal than a blacklist. Blacklists don't win. There's been lots of talks showing how blacklists fail, but it's still used. We always see customers in different environments blacklist net commands and blacklist PowerShell specifically with AppLocker. Well, there's this little trick what essentially allows you to use the sip.management.automation, call a run space, which doesn't ever start a PowerShell.exe. It actually utilizes the backend global assembly cache files that .NET uses. And so in the process list, PowerShell.exe never starts, and it effectively blocks all blacklists or bypasses. And so this is kind of a screenshot to show that. If you're in AppLocker and you go to like a DLL block, like you're trying to block DLLs, you can't even access the DLLs associated with the global assembly cache by default. In the Explorer anyway, when you pull up the nice pretty GUI to like select the DLL that you want to block, anything in the C Windows assembly directory, Microsoft tries to obfuscate the DLLs away from you because they don't want you messing with them as an end user. There's a registry hack of which you can implement to allow you to see those DLLs, but it's rather complicated to actually block this technique that we ended up implementing. And we call that Sharp-Pick. It's been out for a little bit, and the feature stuff was pushed today. So when I put this out, I had a whole bunch of discussion from the offensive PowerShell community saying, well, this is really cool. It's kind of neat to demonstrate the impact and demonstrate to Microsoft that, hey, we should probably block this. But it's not that sexy. You have to put a binary on disk, and it's C#, and there are still ways to block it. And so really, they wanted to execute PowerShell from unmanaged code. So if you can do this in C or C++, it's better, right? Hackers like that language better than C#. And so Lee Christensen, goes by the handle Tifkin, actually put out a project following that discussion called Unmanaged PowerShell. And it allows you to use the CLR and import a .NET assembly from memory, and then actually execute PowerShell code from C or C++. And then I did the easy job of taking all this code that he took time to write and made it into a pretty reflective DLL. And what that basically allowed me to do was allowed me to inject that DLL into a remote process, which would then run PowerShell in that remote process without ever starting PowerShell.exe. And whatever PowerShell I wanted to execute would be in the context of that process. And of course, to add more PowerShell to it, because it's not cool unless there's more, we had a PowerShell script that actually does this. We use Joe Biolic's reflective PE injection to inject our reflective DLL into the remote process, which then kicks off the .NET run spaces.
And we'll show the power of this in the demo. This might not all completely make sense and why exactly you would want to do this, but we'll show in about 30 minutes why it's pretty awesome.
And so this diagram breaks it down a little easier. Basically, we have our PS injector script, which injects into the executable that you want to target, let's say Explorer if you're a user, which then pulls a reflective pick DLL and injects it using Stephen Fewer's method, and then pulls the .NET assembly from memory, and then executes a download cradle to reach out to a remote host and pull the secondary stage into that process. And so when you combine this with other tools, it becomes really, really effective. And again, we'll demo that. And then the obligatory meme, PowerShell and PowerShell and PowerShell.
Yo, dog, I heard you like PowerShell.
I got trolled quite a bit after putting this out of how many layers deep can we go.
Yep. Cool. The next tool, Pew Pew Pew. My boss loves this title. He says it's really awesome. So this is the obligatory meme for this with our big fat American cop, America. So, okay. The whole thing with Pew 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 is kind of like a design pattern, I guess would be the best way to say it. So this invoke mass design pattern, it's a model to run PowerShell scripts on a mass number of machines and retrieve the results all without needing WinRM or PS remoting enabled. You guys are aware of PS remoting? It's this really awesome way that you can run PowerShell scripts like invoke Mimikatz on remote machines without having to do any download cradles or anything else. You can just run it natively and remotely. The problem with that is WinRM is not enabled by default on pretty much anything, I think, except Windows Server 2012. And most enterprise clients that we see are, just now decommissioning their Windows 2003 servers and, having 2008 because everybody always keeps up with all the Microsoft updates, and that's totally what Microsoft thinks. But anyways, so we wanted a way that we could execute stuff through WMI and get the results and run whatever PowerShell script we wanted on a mass number of hosts. There was, I think, Carnal Onage had a blog about this, about using bat files and a bunch of different parts in a little web server to run all this stuff. And there was a blog post by ObscureSec talking about a down and dirty PowerShell web server. So I kind of combined all the approaches. So the end result is a Java-fied web server is kicked off in the background on a specific port, like 8080 or whatever you want to specify. WMI is used to execute the little IEX download cradle on any number of target machines. That download cradle will come back to your pivot box, execute a hosted PowerShell script, get all the results, and then it'll post those results back to that same little locally hosted web server. All the results are going to be saved out to a file, and then you can run whatever parsing and stuff you want afterwards. So we can do stuff like invoke mass mimikatz, which will execute PowerSploit's awesome invoke mimikatz script. If you guys aren't aware of this, you can run mimikatz and inject into LSASS and get all your plain text passwords without having to run an agent like Meterpreter or something else, and without having to drop a binary to disk. But now with this approach, you can run this script on a mass number of machines. We've done dozens. I think it should work up to hundreds, and get all the results without PS remoting. The results are parsed off on a server credential object. It's going to look like this. As a demo, just kind of running out 2 of these servers. I'm doing the verbose thing just so you can see the output. And you're going to get the server and the credentials are going to just start coming back for the LM hashes and also like the plain text stuff that you can see there. So it's cool. One caveat is you do need admin access on the box, the pivot box you're using, so you can actually grab the port and stand up the web server. Yeah, I mean, you have to have, the scenario is you escalate to local admin, you see some kind of, local admin reuse, or you grab, like a desktop admin or server admin token. This is a way that you can, triage very quickly a large number of machines in the domain and get all the plain text passwords back.
But potentially whatever script you're kicking over to the remote host, it's dependent on that. And so if you're not doing mimikatz, but you're doing like a simple download cradle or just, writing out a file, you potentially don't need admin on those hosts. It's dependent on that situation. Yeah, no problem.
So one step further, Microsoft has this other awesome gift for us called the Microsoft Search Indexing Service. So we talked about, kind of that file finder and doing essentially the equivalent of a dir/s and grepping for specific names. Well, my boss, I sent that to my boss. I'm like, this is awesome. And his response was, well, come back to me when you can actually search inside the files. And I was like, God, whatever. So Microsoft does this for you on Windows 7 workstations, right? The little search indexer where you go up and you search for stuff. So if you have admin access to a bunch of machines, you can run invoke mass search. It'll run a PowerShell script on any arbitrary number of machines, query the search indexer for any terms you want, password, specific search terms or something, and post all the results back. The really cool thing is there's this little field called auto summary, which will give you the snippet of text that it flagged on, like that block of like 2 paragraphs of text. So you don't even have to download the file from the remote machine. You can just run this on, a crap load of, server admin machines or, desktop admin machines for specific things like passwords or, like sensitive, project terms or something like that, and get all this result data back without actually having to download the files. I think this is pretty cool. I don't know, most people don't think, people haven't really grabbed onto it yet. But
And then this is the newest edition. It was just pushed out to the GitHub this morning. When I came onto the project, basically I had identified all this stuff. I'm like, man, this project's really strong. Where the hell am I going to contribute here? I'm a new guy in the team, new guy in the project. And I kind of identified that the one last area that we hadn't touched, and likely because it's kind of been talked about heavily in other projects, was the idea of backdoors. Oftentimes we'd be in an engagement and we do all these crazy PowerShell capabilities and offensive stuff, and we never deploy a tool, and then we get to the point of where we want to maintain access on a host, and it's like, well, I guess I got to push out an agent, or I guess I just got to use this asynchronous agent and keep it running at all times. And when you end up with a couple hundred hosts in the network, keeping all these asynchronous agents straight becomes kind of insane. And so I wanted to identify a way that allowed us to either remain memory resident or regain access to systems that we had previously compromised, and do it in kind of a varied way. We say this offense in depth, buzzword bingo here. We want to have multiple techniques in the network. We don't want to ever have a single point of failure.
People have heard of the defense in depth of don't have one piece be the single point of failure. We like to think offense in depth is don't have a single point of failure in your attack chain. If one piece, your one tool fails, your one binary fails, you don't want your whole op to be completely finished.
And so since I was learning PowerShell, I thought, why not do it again in PowerShell so I could be part of the PowerTools project.
Yeah, we should have said the drinking game is if we say power or PowerShell, then everybody has to drink. So you'll probably be wasted by the end of this talk, but have fun.
And basically what I did with this project is my goal was to automate a bunch of non-persistent backdoors, meaning not reboot persistent, that you could put down on a host to regain access should you come back. About 95% of our more advanced engagements, 95% of the time during that engagement, we don't like to put tools on disk. We've definitely moved to a memory-only operating standard, and because incident responders are getting really smart. I mean, we have incident responders dumping memory on us all the time now too, so it's definitely a concern for us. So we wanted ways to be memory only and have varied triggers that caused varied actions to occur. And so we actually broke out like backdoor to be like trigger versus action and actually varied both of them in the environment. And so we're going to talk about some of the cool ones and some of the ones we thought would be most applicable or most usable across engagements. And so this idea actually started really early on before I was ever a civilian or ever in the private industry. And actually it came from the Wipe the Drive talk by Mark Baggett and Jake Williams. Both of those guys, actually, I left out Baggett. He'll make me drink a beer later, I'm sure. And so we actually use in this backdoor, we use get when event in PowerShell to constantly monitor the Windows event logs. And we do so in a way that we monitor only the event logs that we checked since the previous time we checked. And so it's not so intensive on the system, it's fairly smooth. And what we look for is failed logon events, assuming that they're turned on in auditing, that have a certain trigger username. And so this backdoor runs on a system, and as an attacker, if you want to regain access, all you have to do is RDP with a bad username. Generates a bad event, causes this backdoor to trigger, and fire home a download cradle to call home to your listening post. And so it's kind of a neat technique that incident responders often don't catch. It doesn't quite follow the entire theme of the Wipe to Drive talk because they really focused on having things that weren't in memory in general, but doing this in PowerShell, obviously I have to have an execution method and a way to run it. And so the next one was the port knock backdoor. So I got the event logs, I'm like, this is really cool, all right, what else can I do? I wanted a way to actually use a network triggering scenario, or a way to cause your backdoor to call home, but without being identified in TCP view. Specifically for incident response systems, we constantly, like, the first thing to do if they know a red team's on the network is like protect their own system. They don't want us coming to get them. And so we wanted a way to remain resident on that system without getting flagged there. And so we used this git packet script from Robbie Faust, found it on his blog. He was using basically PowerShell to do a sniffer. Starts up a raw socket promiscuously across all the ports on the system, requires a firewall rule and requires admin, so lots of access here. And then I took that sniffer and I looked at every data packet of every packet hitting the system and looked for a magic trigger value. So basically some value that the hacker defines is a way to trigger the backdoor. When I see that trigger value, I call home using PowerShell. And so this allows you to use UDP, TCP, or ICMP to trigger a system. So it's a much more flexible network way to have your backdoor call home.
Yeah, send one ping to an admin system that you want to regain access on. You can get a download trigger back or install an agent or do whatever you want.
And in TCP view, they don't see like a bound to port, something really obvious that flashes red. They might see like because it's a raw socket, they might be something bound to like localhost or doesn't stick out, it blends in with the noise. And then when we do penetration tests, a lot of times one of our common methods is like, oh yeah, you get admin access and you immediately add a backdoor user. Or you take your user that was provided by the customer and you elevate it to a domain admin. And that's how you maintain access. Well, when you do that, obviously, like when they catch it, and a lot of admins are starting to run scripts that monitor the domain admin group in pretty tight environments, they kill that and they kill everything you have if you don't deploy things. And so I wrote a script that could look for either local users or a domain user, and if it didn't find the presence of that user, it would then phone home. So you deploy this out to, 20 or 30 machines in the network, and whenever those incident responders catch you and they delete your user, it trips all the backdoors in the network, and they all start phoning home all at the same time. And it's actually really good because it's like a attacker IDS. It's like, oh, hey, the incident responders are onto you. You have all these callbacks coming home. We really like it. It's a way to help us work in penetration tests where this is a common technique.
I still want to have the callback or the trigger for one of these be re-add the user that they just deleted. So every 10 seconds they try to delete the user, it's magically re-added to the domain. We haven't gotten to do that yet. I still want to, maybe someday when we're messing with some IR guys, we might do that.
Typically on a real engagement, we're trying to vary this tactic. So like, the thing that we're executing as the action is significantly different than the thing that we were using as the backdoor in the first place. We don't want to stick out, but to be trolly, it would be kind of entertaining to do that sometime and watch them wonder from a remote machine, we're running this on 20 systems, how the user was being added. So the next one we call the resolver backdoor. And this is a little stealthier in really tight network situations. We have a couple customers that have really good network monitoring, full take packet capture on all their boundaries and all in between enclaves. And this is what we use in that case. Basically, you provided a DNS hostname, blog.attacker.com, and you give it an IP address that it should be set to. And this thing will, on a certain interval, do just a simple NS lookup or a resolve of that A record. And when it'll look for the IP address, if it matches the value that you defined, it does nothing. It just remains dormant. If it changes to a different IP address, then it will actually cause PowerShell to call home to that IP address. And so it's basically using DNS as a trigger to signify that you're ready for all your callbacks to come home. And obviously, right now, this is kind of proof of concept in that our callbacks are all HTTP or HTTPS. We have DNS text callbacks, they're a little flaky. But in the future, with different actions, you could essentially make DNS your only real network signature here to catch. And it's dependent on whatever you set your A record request to be, and et cetera, whatever you're resolving to. So like I said, all of these backdoors are non-persistent. We typically don't find the need to do persistence when you have a couple hundred hosts in the network. Usually one of them stays up overnight. Not all of them are shutting down overall. And we can maintain access as we need. But if you're into that persistence thing and you really like it, we like to do schedule tasks. It's a really easy thing. It blends for most part. Obviously, administrators and incident responders are catching on to this, but not when you combine it with registry storage. And so when you're not actually putting a file on the file system, but you're encoding your PowerShell payload into some random registry key, and then your schedule task, all it does is ask what that registry key is and execute it with an IEX, it's really nice because you actually have no file artifact on the file system.
And if you want to get really tricky, you can base 64 encode it, you can binary encode it, you can do like kind of basic XOR encryption. You can do things like, if you have a very large file, you can store different chunks of it in different registry keys and have like a little hopper that hops around, recompiles everything. Like your imagination is kind of the limit with doing something like this.
Yeah, it can get quite convoluted, and this actually came and was inspired by a lot of malware over
the PowerLix stuff.
Yeah, PowerLix, and then a lot of malware nowadays, like that you're starting to see reports come out on from all the big threat intel or like AV firms. It's starting to use registry encoding. It's not necessarily a new technique, but it still works quite well because the registry is the wild, wild west. You don't really
AVs don't really scan the registry, so.
And so, I guess the so what here, I'm going to highlight the fact that like when you start combining these tools, when you think of PS injector or the PowerPick ability combined with Power Breach, you now have the ability to stage a PowerShell backdoor into remote processes without ever running PowerShell.exe. You could put this event log backdoor into Explorer, and when you do a quick process list, the administrators don't know what's going on. They're none the better for it. And then you do a fake logon and it triggers. You can really start combining these different techniques. Pew, 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 for example. You could shoot out a whole bunch of Power Breach backdoors to all the systems you have access to, and you don't have to worry about hitting those systems one by one to add these backdoors. And you're pretty well positioned for when the incident responder does finally catch on. So we're going to kind of do our 2 cents. We like to have a defense slide, obviously. And this is short because this is a rather naturally offensive talk, but we'd be happy, again, to catch beers or talk with you about like defensive ideas we've seen. In general, HIPS and whitelisting has really been painful for us on engagements. If a customer does HIPS right, writes the rules to detect most things, and is proper in a whitelisting environment, this is rather complicated even to execute with PowerShell. It stops us. With that being said, there needs to be a better way to restrict PowerShell to certain users, specifically not just PowerShell.exe or some single thing, but the entire use of the assemblies, the framework, and interacting with these different run spaces. We don't really like the fact that in generic it's kind of a puzzle to figure out how to do this in an enterprise environment. And so this is that's what we're trying to push by doing a lot of these capabilities, is to inspire that difference. And if you guys know techniques to block this stuff, we would love to see them, because most of the people we ask.
The number one thing, if we ask, they say, block PowerShell and app blocker. But again, we went really fast over this stuff. But the key with the automation DLL is that PowerShell is essentially a wrapper for .NET. So even if you enroll PowerShell.exe into app blocker, you don't stop the ability to run PowerShell code. That was kind of the big point of all the PowerPick stuff. The automation DLL on the back end and the automation.NET DLL is actually what runs all those components. So if you can load up that DLL into another process, whether through a C# binary or with the PS inject stuff, then you're not actually stopping everything.
And then we like to say another defense slide is like, obviously, it says it perfectly. PowerShell is raw code in memory. It's ASCII. And so if you import a script in PowerShell and you dump the memory space of that process, you have the raw script. So there's nothing magic going on here. It actually makes it really good for a red team environment where you're trying to train incident responders, because it's not so magic that it's impossible to discover what's going on. but it's magic enough to make them work for it and actually do memory incident response, which is what we're trying to push our customers on these engagements to do. Take that next step and just don't run FLS or log the timeline on me. Like, actually take the time to analyze memory, figure out what's going on, and implement signatures based on that memory sample.
There's no reversing with any kind of like this PowerShell stuff. If they dump the memory space, you can get everything that was run. So again, really cool kind of little training component.
Might make it bad on a real world hacking engagement, but makes it real good for red teams. Cool. So we're going to step into a couple different demos. We might start with just the demo for the individual tools. You want to start with that?
Do you have enough time? Yeah, we probably have enough time. Power Breach one?
Sure. Okay. And so we're going to start with Power Breach, and we're going to demo 3 of the different backdoors. We talked about all 3 of them. Basically, we're going to show here that I have my Kali system, I have Apache started, and I have a PowerShell script that basically pops a message box, and it's encoded in base64 on my web server, so it's available remotely.
Sorry, super small text.
The first one we're going to do is the event log backdoor. So you can see here I started the event log backdoor looking for the username of hacker. And so I'm going to pop a little R desktop on my Kali machine, and we're going to wait for the event log backdoor to trigger. It actually sleeps for a certain amount of time so it doesn't overtax the system or it's not too noisy. Obviously, if you watch Procmon or something, you're going to see events occurring. So we didn't want to do it like every second. And whenever it sees the actual event occur, you're going to see it trip off a whole bunch of verbose information because I'm running it in a window with verbose. And then you're going to see it call home, and you should see a message box pop up. So that's backdoor number 1. Backdoor number 2. We're going to do the dead user backdoor. So this backdoor is essentially, again, looking for the presence of a user, and if it doesn't exist, it's going to die. I didn't have the user in place to start to show you that the backdoor, in fact, works. We're going to come to another prompt. We're going to add the user, bad Frank. He's really, really bad. He's my manager. And then we're going to actually start the backdoor up again, and you're going to see that it sits because the user's there. So now we're going to simulate the network defender blocking that user or deleting that user off. It could be either the local system or the domain controller. We have functions for both. There's a flag in the dead user backdoor specify domain. And whenever the poll interval happens, you're going to see another message box pop. Now, the message box isn't what you would do in an engagement, right? That doesn't make any sense.
It's like popping calc.
You might, yeah, it's like popping calc in an exploit. You might use it to, I don't know, DOS the system. Or you might use it to, in a real engagement, you might use it to call home to pick up a secondary Metasploit payload and inject a interpreter using like invoke shellcode or something. In the final backdoor, we spawned, it was really quick, I'm sorry, we spawned the phone home backdoor, the raw socket, and we came over to our Kali Linux machine, and we ran a little controller code that I included in the repo that just sends one UDP packet, which causes the pop-up to occur.
All right, so
we're going to attempt to live now.
Yeah, so pray to the demo gods that we have there. Let's see if this actually works. There's about 15 moving parts to this, so...
We have a video if it fails.
Yeah, if we mess up, we've learned. Okay.
And so we're going to start by basically showing who you are as a user, and we're going to show you that he's not part of the local administrators group. So we're starting from a non-privileged context on a local system. Not there.
Yep.
Yay.
We're going to do PowerShell.
We're going to launch into PowerShell, our favorite attack environment. And we're going to execute what we call the download cradle. It's basically a method of executing code that comes from a download.
Cool. So we're simulating if we had, like our attack toolkit already kind of loaded up on an external jump server. And again, we're not using an agent on here. We're doing everything natively from Windows. So right now, there's several tools that I had in a PowerShell script that are all loaded up now into this one system.
So we're going to do invoke all checks from PowerUp, which will basically look at all the different methods of privilege escalation. You'll see a couple hit here, specifically the service user add and the path DLL hijack. The service exe is much easier to exploit, and you don't have to do any rebooting or anything. So we're going to just demo that one real quick. So we're going to invoke service add, which exploits that privilege escalation vulnerability.
Sorry,
demo gods, demo gods, demo gods.
Yeah. Username tab.
So this will actually create a service executable, a hot patch of service executable.
This is the vulnerable service itself, not the exe. Cool.
So added the user to the local administrators group via that exploit. And so now you should see we're a local admin. Yay. Privesk. So the next step. going to run as an admin, get an admin prompt on the system, bypass UAC and all that.
X.
So we're going to execute our download cradle again in this new session to re-get our toolkit back into memory as an admin context. So now we loaded it all up into memory. And we're going to find all workstations on the local network that where our current user has local admin access. So this will actually go system to system and check what we're able to access on that system via SMB. And so you'll see that these two different systems, one being yourself, is the targets in which we have local admin access. And so now we're going to move on to targeting that system as a local administrator. We're going to do this using invoke mass mimikatz. We're going to take that system and we're going to dump its plain text creds. This takes a second. It actually initiates the web server, so it stands it up, binds to a local port, serves up both the file and waits for the post responses to come in with the credentials. Takes all in what, about a minute to execute?
Just depends, yeah. Like the timing's set up kind of in this way. If you're running it on a large number of machines, it tries to take spacing between each one so stuff doesn't stomp on each other.
What's the largest number of hosts you've run this on? No.
I think about 100 or something like that.
And so what's going on right now is it actually served up using WMI. It calls the download cradle to come back to our local server, pull the invoke mimikatz script, execute it, and post those results out to your prompt. It also gives you output. So now we're going to use that password that we just dumped to log into that system with RDP. Yay, super secretive RDP, which we find all the time in enterprise environments, all hosts. Now we're interactive on that system. We're going to pop open the task manager so you can see the injection part that's coming. And then we're going to start up a command prompt and get PowerShell up again. So now we're on a remote system that we just got access to, Power View, which we had the credentials for via Power Up. And we're going to download this time, we're going to download the PS inject script into memory.
Work. There we go. All right.
And so now we're going to execute that PS inject script to inject into what process are you going to
first, let's see. Which one am I going to do? VMware Tools. Let's do that one.
We'll inject into VMware Tools.
1736.
And when we inject this PS inject into VMware Tools, it's actually going to execute another HTTP download and pull the secondary stager. What we're serving up here, what you're going to see is we're going to serve up a power breach backdoor. And so we're simulating right now if we were leaving this system for a long period of time and planning on coming back later to retrieve whatever we needed to. So it does a whole bunch of memory stuff, loads all the required DLLs, and injects it. So this is where real demo gods need to come in handy.
Yep. Let's see if that works. So you see here now, there's no PowerShell running. Cool. Then we are going to, I'll show here what's actually going to be running. So
this is a script that we actually served up.
Yep.
So it's power breach with just a single command at the end to actually run the specific module that you wanted to run.
Let's see.
So this is the domain controller, and we're assuming here now that the incident responders have caught us and that they're going to delete our backdoor user, cleverly named backdoor. And hopefully what we have happen is a shell pop up.
If not,
we have to wait for the poll interval, obviously, so it could take some time. If not, I'll give you a pretty demo on a video. Bam! Yay! So that was triggered simply because the incident responders deleted our backdoor. And now we have an interpreter shell on the system, maybe on the domain admin system, that would allow us to go get interactive again and re-add or implement some backdoor again. And so here's our contact info. We're super open to chatting on all of this stuff. We like community participation. It's all on GitHub as of today. And so if people have ideas for cool modules or cool actions, definitely go check it out and submit pull requests. We'd love for people to help out. Or if you just have questions about how to use it, you're on an operation, you're on an engagement, and you're like, man, I'm 10 feet deep in this network and I'm trying to use your tool and it's not working, please reach out. We sit on IRC and the Vail channel as well as Armitage. And we're pretty reachable.
And we'll be in the hallway for a little bit right after this in case people want to talk offline. Yeah, I mean, unless you, so Emmet, the question was, do the scripts work against Emmet? So by default, Emmet doesn't enroll PowerShell because it's not a normal initial exploitation vector, because Emmet's normally designed to block those initial exploitation components to get into a system. It's not meant to stop post-exploitation. We have done a little bit of experiments with enrolling PowerShell into Emmet, which can stop things like shellcode injection for like PSExec, PSH. But for all these kind of actions, it's not injecting shellcode, so those ROP chain components aren't going to like come into it. There's no memory corruption. There's not that kind of injection. So as far as we know, we haven't done extensive testing, but I don't think this should be stopped against Emmet. Signing. So the question is, have we encountered an environment where signing is required for PowerShell scripts? So signing is not a security boundary. People think it is. So even if you require signing, when you launch PowerShell, if you do -exec bypass, it turns off all the signing requirements. And actually here, we don't even care about doing exec bypass, because if you do that little, that only matters if you're loading PS1 scripts off the machine, like, you know, into the process. So if you do that little IEX download cradle from a different location, execution policy doesn't come into play in any way whatsoever. So, and thank you, Microsoft, for doing something like execution policy and then doing a flag that says turn off execution policy. That totally makes sense. I mean, people get confused because a lot of admins think I'm secure because I have signing. It's absolutely not a security boundary in any way whatsoever.
In its current implementation.
Yeah. Maybe Magic PowerShell 8 or something will actually do it correctly. But cool. Any other questions? No? Cool.
Yeah, find us after if you want to grab a beer.
Yeah.
Stuff. Thank you.
Cool.